Hello everyone, so welcome to the Class 12th Board series. The first chapter here is Haloalkanes and Haloarenes, which will be very helpful for NEET, boards and even JEE mains. Okay, so make sure you watch this video fully because everything from the classification till the end point, that is DDT, will be covered in this video. Okay, please don't forget to like the video because it takes a hell lot of effort in order to make these type of videos. Okay, so let us begin with the video. The first part here is that what is the actual meaning of the haloalkanes and the haloarenes. The substitution of the hydrogen atoms in the aliphatic or the aromatic hydrocarbons by the halogen atoms results in the formation of haloalkanes or the haloarenes. Basic definition, like for example, I have been given benzene here. Let me say we replace only one hydrogen in order to give me the formation of chlorobenzene. So this would be known as a haloarene. Similarly, अगर मैं किसी हाइड्रोकार्बन को लेता जैसे फॉर एग्जांपल इथेन, अगर मैं इसको कन्वर्ट करता this in this compound, then this would be known as the haloalkane. Okay, so that is how we deal with it here. The first part is that classification of the halogen derivatives. So on the basis of the number of the halogen atoms present, the halogen derivatives are classified as mono, di, tri, tetra, etc. halogen derivatives. Examples are, let me take the example, जो example मैंने यहीं पे लिखा है. This type of compound which has only one halogen would be known as the monohaloarene. Okay, general naming would be done in mono because one is present, halo because halogen, arene matlab because of the aromaticity. Okay, if I would have C2H5X as I have written here, okay, this thing would be named as mono because one halogen. Here we have halogen, that is why halo, and moreover alkane because ये aliphatic है. In this manner we would name it. If I would have CH2X, like for example इसके ऊपर मैंने dichlorination किया, then we get CH2X, then we would name this compound as di, mono की जगह dihalo because two halogens are present and we have alkanes. Simple points but missed by many people. Okay, so this is the first point we have discussed. Now the next classification can be done on the basis of the carbon to which the halogen atom is attached. So halogen derivatives are classified as 1 degree, 2 degree, 3 degree, allylic, benzylic, vinylic or aryl derivatives. Okay, so please understand the red ones which I have labeled. 1 degree, 2 degree are very easy. Like for example, I have a carbon atom here. Okay, which is attached to a halogen. Let me say that it is attached to two hydrogens and we have one group only. Let me say R is some CH3, C2H5, whatever. So this type of halogen or this type of thing would be known as the 1 degree. Okay, and similarly, if I would replace one of the hydrogens with some R1, here we have R, H, X, this would be known as a secondary or a 2 degree. Similarly, if I replace this third hydrogen which is present by another R, then this would be known as a 3 degree. Okay, so first point is clear. Now what is allylic? Allylic is very important because of the resonance phenomena. Allylic क्या होता है? Let me say we have CH2 double bond CH, CH2X. So this is known as allylic. Now why it is very important, वो तो SN1 SN2 में पता चल जाएगा. But simply you can guess that even, let me break this thing from here. Okay, in whatever manner. First of all, I form a carbocation that will also be stable because of resonance. I form a carbon ion that will also be stable, and radical would also be stable because of the resonance which is possible from here. Okay, so allylic would have the stability for all the intermediates which can be formed. Next we have the benzylic. Benzylic मतलब क्या होता है? Many people are confused. This CH2X, when X is attached to a carbon which is directly attached to this ring, that is CH2, this is known as a benzylic. Next we have vinylic. Vinylic क्या होता है? That is CH2 double bond CHX. That is this carbon wouldn't be there. This is known as a vinylic. No resonance would be present. People are confused between those two because I have drawn this simultaneously, so the confusion should be clear to you. Aryl क्या होता है? Aryl is basically that the halogen is directly attached to the ring. So this is known as the aryl derivative. Okay, so I hope that these all are clear right now. So one of the most important phenomena, that is the general methods of preparation of haloalkanes. So first of all, we have from alcohols. These three are the important ones from the board point of view and NCERT. So first of all, कैसे करना होता है? यहाँ पे phosphorus की oxidation state is equal to +3, यहाँ पे is equal to +5, यहाँ पे is equal to +6, +4. I'm sorry. Okay, so you can calculate the oxidation states. Now ROH, first of all, we'll get RCl in all of these three. Okay, RCl तो सब में आ रहा है, but that is not the important point here. The important point are the byproducts. +3 oxidation state, so final product should also have a +3 oxidation state. So H3PO3 will be formed, which also has a +3 oxidation state. Okay, now here we have +5 oxidation state. So +5 oxidation state क्या हो जाएगा? POCl3 plus HCl gas would also be released. Okay. Now in this case we have a +4 oxidation state, so we would have SO2 which will be released and HCl will also be released. Now you can see that this also has a +5 oxidation state. The confusion which comes in our mind is that H3PO4 क्यों नहीं बन रहा है? That can also be formed on the further hydrolysis of POCl3. इसको hydrolyze करो, OH, H, OH, H, OH, H. You can see H3PO4 will be also formed on further hydrolysis. So first of all POCl3 बन रहा है, उसका further hydrolysis के बाद we can also get H3PO4. So not a big deal. Important point to note here is that the best method for preparing alkyl halides from alcohols will be the Darson procedure. This is also known as a Darson procedure. Why I've taken the name? Because it has been asked in BitSat. Okay, so that is why. So Darson procedure बोलते हैं इस चीज को. You can see SO2 भी gas है, HCl भी gas है. In the other cases, these are basically the solids or in the liquid form, mostly the solid form. So that is why in this case these are released in the atmosphere and only this stays in the container जिसमें reaction हो रहा है. Okay, so that is why we get the highest purity of the RCl. And you can see that these are byproducts and they escape easily. So this is the best method for preparation. So this should be known to you. What will be the reactivity order? That is very easy to guess from inorganic point of view. HI, HBr, that is greater than HCl because HI bond will be weaker because I is having a larger size. So that is why HI को हम easily तोड़ सकते हैं. So that is why we would see that this would react in the fastest manner. Next we have the free radical halogenation of alkanes. Now first of all let me take the help of a simple example. We take a butane, that is the N-butane here. We react with Cl2H-mu. H-mu मतलब हमेशा radical बनेगा. H-mu can also be given or heat can also be given, which is useful for the radical formation. Mostly H-mu will be given. Okay, so radical बनाओ. So radical will be formed in this manner. Okay, or it can also be formed on the primary one. Only two cases are there जहाँ पे मेरे पास radical बन सकता है because all other would be identical. Cl2 से I would get the Cl radical formation. So react it with Cl radical. We would get the formation of the alkyl halides as you can see. So you can see that that mixture of two alkyl halides will be formed, in which this one will be major because of the secondary nature of the radical. So you can see that this can also be used for the formation of the alkyl halide. Okay. Now we have the addition of the hydrogen halides on alkenes. For example, let me say we have been given this compound. We react it with HBr. Very simple thing. H plus है. H plus is electron deficient. This is electron rich. So electron rich would react with the electron deficient, giving me the formation of the carbocation. This carbocation is stable in the present compound. Br minus आएगा. That would go and attack this plus charge, giving me the formation of the alkyl halide. So once again alkyl halide is formed. But what has actually happened if I would have taken the presence of the peroxide? So like H2O2 is a peroxide. Any peroxide can be taken, R2O2. I am taking H2O2 here. So अगर peroxide होता है, due to the anti-Markovnikov effect, instead of the formation of bromine here, that is on this carbon, we would get the formation on the adjacent carbon. That is the only option left. So that is why in this case we would get the formation of the bromine onto this carbon. So once again you can see that we can form the alkyl halides in this manner. Everything is taken from the NCERT so that तुम्हें NCERT वापस खोल लेना पड़े. Please don't forget to like the video. We have the Finkelstein reaction. इसमें क्या होता है? We take any alkyl halide, we take NaI in acetone. Now why acetone is taken? It is non-polar solvent, so that is why we have I minus. So I minus has the highest nucleophilicity in that, so that is why we get the formation of Ri here. So that is the Finkelstein reaction. Schwarz reaction क्या होता है? Let me take CH3Br, whatever that is CH3X basically. We take AgF, that gives me the formation of CH3F. That is, alkyl fluorides can be formed with the help of Schwarz reaction, and alkyl iodides can be formed with the help of Finkelstein reaction. Very two important reaction. Let us move on to the next important name reaction, that is the Hunsdicker reaction. इसमें क्या होता है? We have been given CH3C double bond O, OAG. Okay, for हमारे पास acid था, we reacted that with AgOH to give me the formation of this compound. Now if we take Br2 in the presence of CCl4, what actually happens from here is that, kindly see it, this would help you in keeping in mind. Br यहाँ पे भेजो एक, and one Br onto this side, so we would get the formation of CH3Br. From here we would get the formation of CO2, and from here AgBr would also be formed. So this is the very important Hunsdicker reaction. Next we have some physical properties, very basic properties of haloalkanes given in the NCERT, so I have taken here. Boiling point orders of this would be greater than the bromide, chloride, halide, fluoride, because of the molecular mass. Higher the molecular mass, the higher will be the boiling point. We are not considering hydrogen bonding because that is not possible here. Next we have this particular case. Here also we would see that we would have the formation C. We have been given this tertiary, this and this. You need to remember that linear also has the higher boiling point than branched because of the factor of the surface area. More the surface area, you can take a container which has more surface area and the container having less surface area. So more surface area would obviously take more amount of time to boil. So that is the logic. Here also we have this particular thing which has been mentioned. Okay. Now here this is X. Okay. So more number of carbons, that is more mass. So that is why the boiling point increases. So molecular mass once again. The second point here is that the bond strength of the haloalkanes decreases as the size of the halogen atom increases. Thus, the order of the bond strength will be fluorine, chlorine, bromine, iodine. Now, why is this the case? You need to understand here. Very simple logic. Iodide is larger in size, fluorine is closer in size. So when you take two atoms which are closer in size, they would form a better bond. Instead of taking a larger atom like iodine, that bond would be very easy to break. Okay, the similar logic which you have applied here, or you can say that this bond is easier to break because it has a larger size of iodine. Okay, dipole moment decreases as the electronegativity of the halogen decreases. For example, the fluorine will have the more dipole moment than iodine because it is more electronegative, so it can withdraw in a better manner. That is the minus I effect basically. Okay, now we have the haloalkanes are polar but are insoluble in water because they do not form the hydrogen bonding. So if they had formed the hydrogen bonding, they would have been soluble, but they do not form hydrogen bonding. Thus, these are insoluble in water. The density order is this one because mass increases, so density increases, so remains the same for the same alkyl group. Next we have the chemical reaction of haloalkanes. We move on to the nucleophilic substitution reaction. I have taken some very important examples here. These four are the most important. So we have NaCN, we can take NaCN, we can even take KCN. Basically I want to take some reaction which is ionic in nature because it is Na plus and Cn minus. So Cn minus का मतलब क्या है? That the negative charge is on carbon. So negative charge carbon के ऊपर है. So it will go attack this carbon, take out the bromine from here. Nucleophilic because it has a negative charge. So that is electron rich. So we get the formation of CH3, CH2, C triple bond N here. Now we have KNO2. KNO2 मतलब क्या हुआ? The negative charge would be present. NO2. This would be formed. Okay, I'm sorry. KNO2 would have this structure, that is a negative charge is present on oxygen. The nitrogen has a lone pair, but you need to understand that a negative charge would obviously attack better than the lone pair. So we would have the negative charge that would go and attack this carbon, take out the bromine. Okay, so what would happen from here? We would get CH3, CH2, O, N double bond O from here. We have AgCN. Now you need to understand the logic. AgCN is covalent. Matlab, there is no ionic nature in it. So it means that it wouldn't dissociate in plus and minus, but it would remain as AgCN only. That means the lone pair is present on nitrogen. Kahin bhi we don't have a negative charge, only the lone pair is present. So that lone pair will go and attack this carbon, take out the bromine from here, giving me the formation of CH3, CH2, the nitrogen will be attached to carbon. The final product will be the formation of the isocyanide. Okay, here cyanide was there. Okay, and here we will get isocyanide. Here we have AgNO2. Once again, you can guess what is going to happen. AgNO2 का structure होता है AgO, N double bond O. Okay, once again, no nucleophilicity. Lone pair is present on nitrogen and oxygen, but nitrogen is a better nucleophile because oxygen is more electronegative, so वो अपना lone pair रखना चाहेगा. But nitrogen is less electronegative, so that would attack, take out this. So nitrogen will be now joined to the carbon. So we will get the formation of CH3, CH2, N double bond O, O minus plus. It is also known as nitroalkanes. Now we have RO minus Na plus. We have CH3, CH2, Br. This minus would go this and attack this, taking out Br, giving the formation of RO, CH2, CH3. Also, this is a very important reaction which will be discussed later also, but I hope that these points are clear. Now let us move on to the very important SN1 and SN2 reactions. So SN1, the one gives you the feeling that it is unimolecular reaction and it proceeds in the two very important steps. Let me make you understand the logic. We have been given this tertiary alkyl halide here. The step 1 is the removal of X minus, which is the rate determining step because it is slow in nature. The slowest step is the rate determining step, and that is why this is the rate determining step. We get the formation of this carbocation which will be formed. Okay, and X minus would also be present. That is, ion pair would be formed, or basically in layman language you can see that the carbocation formation is there. Now we have the nucleophile, let me say some Z minus, which comes from outside. This step is a fast step. So this is not the rate determining step. You are the rate determining step nahi hai. Only this is the rate determining step because this is slow in nature. Fast step में क्या होगा, इधर से attack करेगा, या तो इधर से कर सकता है, या तो it can attack from the backward direction also, giving me the formation of, I'm just writing the product right now, I'm not writing the retention and inversion. We get the formation of this product. Okay, so this is how the simple reaction mechanism occurs. Please note that the carbocation is formed, so rearrangement can occur. Okay, we are dealing only from the NCERT point of view, so that level of questions wouldn't come, I hope so. The rate of the reaction is K into, that is a rate constant, Rx की concentration, that is Rx की concentration only, that is why it is SN1 first order reaction. Reactivity order of alkyl halide towards SN1 reaction mechanism is 3 degree, 2 degree, 1 degree because carbocation is there or basically ion pair is there. So you can see that plus charge is there, so that would be the most stabilized on the 3 degree. Polar solvents, low concentration of nucleophiles and weak nucleophiles favor the SN1 mechanism. This would be taught to you, wait for it. Polar solvents are those like water, etc. They stabilize, okay, they favor the SN1 reaction mechanism. Now in SN1 reactions, partial racemization can occur due to the possibility of a frontal as well as a backside attack on a planar carbocation. अब इसको अच्छी तरह समझना है. The carbocation, as you can see from here, is this structure which I have drawn. ये carbocation बना है मेरे पास. It is a plane. Now why this is a plane? You can see sigma, sigma, sigma. sp2. sp2 मतलब क्या? Trigonal planar. It means that the compound is a planar compound. So the nucleophile which has been given to you Z minus, that can attack from the front. So thus that would be known as a frontal attack. जब सामने से attack कर रहे हैं, and when it attacks from behind, then it would be known as the backside attack. Okay, so that is why we get the formation of, when it attacks from the front, we would get the formation of this structure, when it attacks from the behind, we get the formation of this structure. So you can see that we can get the formation of, this would be the retention, this would be the inversion. So that is why the partial racemization occurs, due to which we get the formation of the retention plus inversion in this particular case. Okay, so I hope that this logic is understood. We have SN2 reaction now. These reactions proceed in a single step and second order, in which we get the relation to depend on Rx and the concentration of nucleophile also. During SN2, inversion hota hai, that is the Walden inversion, which starting with the dextrohereditary halide, a LEVO is formed. Like D से मेरे पास L बन जाएगा और vice versa भी हो सकता है. Okay, let us try to understand with the help of an example. So this is the reaction mechanism. This is a nucleophile which attacks from here, takes out this thing, but in the formation, this is the intermediate, which is known as a transition state. So in the case of SN2 mechanism, you can see that the intermediate is a transition state which is formed where the nucleophile has a delta plus charge, the leaving group has a delta minus charge. So we have the removal of the minus X minus from here. So we get the formation of this product which has the inverted configuration of the initial one. So in this case, we get the inverted product to be the major one. So you can see that inversion would occur here. Okay, now the reactivity of halides towards SN2 is 1 degree, 2 degree, 3 degree. Why? Because Z minus usko attack karna hai. So the nucleophile needs less crowding. So less crowding किसमें होगी? 1 degree में, then 2 degree, then 3 degree. Rate of the reaction in SN2 depends upon the strength of the attacking nucleophile. The logic is clear. The rate depends on the concentration of the alkyl halide and the nucleophile. So nucleophilicity बढ़ाऊंगा, thus we can see that the SN2 mechanism increases. Strength of the nucleophile has been given here. Non-polar solvents, strong nucleophiles and high concentration of nucleophiles favors the SN2. Why? Because it is a second degree, that is the order is 2 basically, so it depends on the concentration of nucleophile and alkyl halides. So if concentration of nucleophile increase karta hun, so SN2 increases. Okay, now let us try to understand some examples here. So this is the part which is given for SN1 question. So we have been given a tertiary, this is now once again here. So the rate of this would be greater than this would be greater than this. Now many people are confused here, but in the NCERT it has given this order, so you need to remember this order, that this is greater than this and this is greater than this. Okay, many books give it to be equal or something, but this is greater. Similarly, this would be greater than this because no resonance here. Okay, and this is a, this carbon would have 2 carbons attached to it, so thus more plus I, thus this would be more stable than this and this. So this is the relative rate in the SN1 mechanism. Now benzyl carbocation would also be very stable. Now why that would be very stable? The people should know that from class 11th. If you draw the resonance structure for it, you would see plus charge hai, electron rich hai. So this bond from here would go along here, giving me the formation of a new double bond. The plus charge would be formed here and this structure would be formed. Similarly, you can draw the other structures where this bond moves from here to here, giving me the formation of double bond. This double bond is here, double bond CH2 and plus would be here, and similarly all the other things which would be going on. Okay, so you can draw the other structures. So these are some of the resonance structures of the benzyl carbocation. The relative reactivity of the alkyl halides from the same alkyl group R is Ri, RBr, RCl, RF, once again because Ri bond is easy. After discussing the substitution reaction, let us move on to the elimination reactions now. Dehydrohalogenation is a beta elimination reaction in which the halogen is removed from the alpha carbon atom and the hydrogen from the beta carbon according to the Saitzef rule. Very simple example, let us try to understand. We have been given this bromine here. We take alcoholic KOH, which gives me the Saitzef elimination. Saitzef, basically elimination is dehydrohalogenation in this particular case, which implies the removal of HBr. So H can be removed from here, Br. So HBr can be removed from here or HBr can also be removed from here. Dehydro, hydro matlab hydrogen, halogen matlab halogen. So basically HX is removed here. Okay, so let us remove from here. We get the product formation to be this one, plus if we remove from here, we get the product formation to be this one. Now this product will be the major product because it is Sadzef and this is Hoffman. In the case of alcoholic, which Sadzef is major, so this will be the major product which will be formed in this particular reaction. Now the ease of dehydrohalogenation among the halides will be 3 degree, greater than 2 degree, greater than 1 degree. That is basically CH3 whole thrice CCl would be greater than CH3 whole twice CHCl would be greater than CH3 CH2Cl. Okay, now let us move on to the reduction part. So we have this compound given to us. We take H2Ni heat. So what would happen in this particular case? The reduction would happen, giving me the formation of this ethane, which is written. Ethane would be formed along with, see, one H has joined here, so H and Br would give me the formation of HBr. So HBr will be formed here. Similarly, यहाँ पे क्या होगा? We get the removal of I2 from here and H will be joined here, giving me the formation of ethane once again. So once again ethane will be formed here and the removal of I2 would occur from here. Okay, so this is how the reduction would occur in this particular case. Now we have the reaction with metals. First of all, we take the Wurtz reaction. Wurtz reaction में क्या होता है? We get the formation of the symmetrical alkanes or aliphatic to be formed. So basically 2Na दिया हुआ है, X and X would be removed, so giving me the formation of RR which will be joined together, and moreover we get the removal of 2NaX. Okay, similarly now we have Wurtz-Fittig reaction. What actually happens is the similar thing happens here but symmetrical नहीं होता है. So you can see that 2NaCl will be removed from here. We get the formation of benzene and CH3 to be joined, which is known as toluene, and 2NaCl will be removed from here. Now we have reaction with Mg, which gives me the formation of the very famous Grignard reagent. So what actually happens from here is that you can guess, we have this thing which is written here. Now we have Mg, we have Br to be formed, which is very popularly known as the Grignard reagent. Okay, so Grignard reagent is never isolated in the solid state because it is explosive in the dry state. Okay, so that is why it is used in the ethereal solution. That is why we always use some ET2O or dry ether, whatever, some aprotic solvent is obviously used so that it is not isolated in the solid state. Now we have the isomerization, which has been taught to you in the class 11th also. Whenever we have been given any alkyl halide, we take anhydrous AlCl3. That helps in the isomerization. Isomerization matlab isomers of this can be formed from here. So you can see that the isomer of this is basically the secondary one which would be formed. So in order to isomerize this to this, we can use anhydrous AlCl3. Now let us move on to some method of preparation of aryl halides. Alkyl halides हो गया. Now aryl halides पे deal करते हैं. First of all, we have the halogenation of the aromatic hydrocarbons. Please focus on this very properly because it is very important. We have been given a benzene ring here. We take Cl2. We take a Lewis acid like FeCl3 or anhydrous AlCl3. ऐसा कुछ भी ले लो जो Lewis acid है basically. So what will happen is that, let me say AlCl3 लिया. So AlCl3 plus Cl2 would give me the formation of Cl plus and AlCl4 minus. So you can see from a Cl plus बन रहा है which is electrophile. So electrophile बन गया. Benzene is a nucleophile. So nucleophile भी है, electrophile भी है. That is acid base reaction can occur, giving me the formation of the chlorine to be attached on the ring. So halogenation on the ring हो रहा है, that is on the aromatic hydrocarbons, which is an electrophilic substitution reaction. Now let us deal with the side chain halogenation. So first of all, we have been given toluene here, that is CH3 has been attached. We want the halogenation on the side chain. Side chain मतलब जो CH3 है उसके ऊपर halogenation चाहिए. So we take Cl2 in the presence of H mu. Why H mu? Because that will help in the formation of the radical. So radical will be formed onto this carbon, that is CH2 radical will be formed. Cl radical would be there, which would join with it to give me the formation of CH2Cl. Now once again we take Cl2 H mu. So once again radical will be formed here, giving me the formation of CH, Cl, Cl, once again take Cl2H mu. So once again this radical would be formed here, giving me the formation of CCl3. So this is known as a benzene. Basically a trichloride is formed here. So the basic point to note from here is that when we need the halogenation on a side chain, we go by the radical procedure. When we need the halogenation on the ring, we go by the procedure of the Lewis acid. Okay, you can see that the free radical mechanism is involved in the side chain process. We have the benzene diazonium salt. So benzene diazonium salt is this one. So these two reactions which I'm going to do, let us try to see kya hone wala hai. CuCl HCl should give you the feeling that chlorination would occur. So that is definitely right, chlorination would occur. This bond is very unstable, so this moves from here to here. That is, nitrogen will be released. So that is why we get the formation of benzene which will be attached to the chlorine and nitrogen will be released. Similarly, CuBr, HBr में क्या हो जाएगा? We will get the formation of the bromobenzene and nitrogen will be released. Now these two reaction sets are known as the Sandmeyer reaction. So very important, should be kept in your mind that Sandmeyer reaction में क्या हो रहा है? These two are the Sandmeyer reactions which are occurring. Now we have CuHCl, CuHBr. Once again the similar products will be formed. Let me say ये product A है, ये product B है. So once again यहाँ पे मेरे पास product A है आएगा and once again here we would get the product B. So this reaction set is known as the Gotter-Mann reaction. Please focus the difference in the reagents which are used. Now we have HbF4 and 273 kelvins, that is a low 0 degree Celsius basically. So here we get the formation of the first of all we get the formation of this thing, that is 0 degree Celsius. So the aromatic diazonium salt is stable in nature. Okay, so वो पहले stable है. That is why please note there would be the diazonium salt to be there only. It would not break because temperature is low. Everything is logical. Here we have BF4 which I have written. Now we heat it. अब मैंने heat किया, then we have the removal of the nitrogen from here and BF3 is also removed. So this reaction happens here, giving me the formation of the aryl fluoride, and nitrogen will be released and BF3 would also be there. Okay, so this is how you can form these things. Now you would be wondering that halide iodide कैसे बन सकता है? So उसके लिए बस simple Ki heat लेना. So this is a very good nucleophile. I minus is a very good nucleophile and a very stable leaving group. So that is why I minus would go attack this, taking out everything, giving me the formation of the aryl iodide. Okay, so this is how you do the halogenation on the ring by one of these methods. Now from phenols, this is not a very good method actually because the oxidation of phenols can also occur, but still we can use it. We have phenol plus PCl5, that gives me the formation of the chlorobenzene, plus HCl plus POCl3. Not a very good method which I would say to prefer, but given in the NCERT, so this can also be done. Now let us move on to some physical and the chemical properties of aryl halide as given in the NCERT. So aryl halides are colorless liquids or colorless solids with characteristic odor. Like if you would have performed the lab experiments, you would definitely know that by guessing the smell only, you can identify that kaun sa aryl halide hai. Okay, boiling point generally increases with the increase in the size of the aryl group or the halogen atom. Same logic, molecular mass. So that is why you can see that the iodide would have greater than the bromide, fluoride, etc. The melting point of the p isomer is more than the ortho and the meta isomer. Why? Because very simple, it has been taught to in GOC also due to the more symmetrical nature. So melting point depends on the symmetrical structures. So जितना symmetry होगा उतना ज़्यादा melting point होगा. So that is why that would be greater for the para isomer because that is symmetric. Now due to the resonance in the chlorobenzene, the CCl bond is shorter and hence its dipole moment is less than that of the cyclohexyl chloride. What I basically mean to say here is that we have been given this chlorobenzene and cyclohexyl chloride. Okay, so dipole moment basically for the cyclohexyl chloride would be greater. Why? Because this bond is shorter. If you would draw the resonance structure, you would see that we would get a partial double bond here. Okay, so double bond aa raha hai, iska matlab kya? This bond is shorter in comparison to this bond, so that is why this would attract better and hence this would have a more dipole moment. So that is the point which I have mentioned here. Okay, let us move on to some chemical properties of the aryl halides. Nucleophilic substitution reactions. Aryl halides are very less reactive to the nucleophilic substitution reaction. Why? You can understand that. Benzene क्या है? Benzene is electron rich. Okay, because it has lone, you can see it has the double bonds which are electrons only basically, so it is electron rich. So why would electron try to react with the electron? But the reasons are the following. Let us see. Due to the resonance, the CX bond has partial double bond character. अगर halogen होता है, that has a partial double bond character. Told to you. Stabilization of the molecule by the delocalization of the electrons. That is, resonance is there in these type of structures. So that is why also we get the stabilization. Instability of the phenyl carbocation. That is, if you remove the X minus from here, we get the formation of this carbocation. I have told you multiple times that whenever the charge is on the ring, we don't have any resonance. So that is why this would be very unstable in nature. Okay, so that is why this point has also been mentioned here. However, the aryl halides having electron withdrawing groups like NO2, SO3H, etc. at the ortho and the para positions undergo nucleophilic reaction easily. Like for example, I have been given nitrobenzene. So nitrobenzene के अगर तुम resonance structure बनाओगे, let me draw one resonance structure for you. So वो ऐसा कुछ बन जाएगा, double bond O, this double bond N, O minus. Okay, you can see that the plus charge goes inside the ring. If you draw more resonance structure, the plus charge goes inside the ring, जिसकी वजह से the ring becomes electron deficient. Okay, so that is why it can give the nucleophilic reaction, because it has become electron deficient. Okay, very simple logic. Now the presence of the electron withdrawing groups like NO2 increases the reactivity due to the logic which I have told here. Okay, so I hope that this is understood. So like you can see, मेरे पास यहाँ पे इस रिंग के ऊपर सिर्फ एक NO2 है, यहाँ पे here I have 3 NO2s. So you can guess from here that the rate of the reaction for this second one, that is picaryl chloride, would be greater than the first one, because more NO2 means more withdrawing nature. More withdrawing nature means more nucleophilic reaction reactivity. Okay, so you can see that H2O, that is basically the OH minus which is present, would go and replace this, but we had to provide some heat in order for the reaction to occur, giving me the formation of this particular compound. Similar thing can happen here, giving me the formation of OH, but here we don't have any room heat required. Even it can occur at the room temperature. Why? Because you can see that we have 3 withdrawing groups which increase the reactivity. Now let us move on to the electrophilic substitution reaction. Nucleophilic हो गया. Halogens are deactivating but ortho-para directing. Thus, chlorination, nitration, sulfonation and Fidelkraft reaction gives a mixture of the ortho and the para chloro substituted products. Okay, so this I have told you multiple times. Like for example, I have been given chlorobenzene. I take FeCl3 and Cl2. So you can guess, I have told you क्या होने वाला है. We get the formation of Cl plus, which will be the electrophile. I have told you the mechanism. Cl plus can go and react at the ortho or at the para position. Okay, so we get the mixture of these two. So what will happen from here? We get the formation of this at the para, and for the ortho one, we get the formation of this dichloro product. Which will be the major one? The major one will be, okay, now this question is homework for you. Kindly let me know that if the para is the major one or is the ortho is the major one. Mention in the comment section that is para major or ortho is major. Let us try to see कितने लोगों को आता है. Now let us move on to the next one, which is the nitration. Nitration मतलब क्या? Introduction of the NO2 group. So once again we have been given chlorobenzene here. We take HNO3. We take concentrated H2SO4. This is the nitrating mixture which is taken in order for the introduction of the NO2 group. So once again you can guess क्या होने वाला है मेरे पास. We get the formation of NO2, and here also at the ortho position we get the formation of the NO2. So once again you can decide that is ortho major or para major. Mention in the comment section that दोनों में से कौन सा major आ रहा है. Now sulfonation reaction. We take concentrated H2SO4 heat in order to give me the sulfonation. So once again SO3H is introduced at the ortho and at the para position. Now we have the Fidelkraft reaction. There are two types of Fidelkraft reaction. One is the Fidelkraft alkylation. One is Fidelkraft acylation. what is the difference between the two? In alkylation, we introduce an alkyl group. In acylation, we introduce the group that is having a carbonyl. That is the acyl group basically. So we have this thing here, CH3Cl, AlCl3, you can guess, CH3Cl plus AlCl3, Lewis acid hai, so we get the formation of CH3 plus, that is the carbocation, and AlCl4 will be formed. Now this is an electrophile, benzene is a nucleophile, so both of these react, giving me the formation of the major product where the CH3 will be joined at the para position. Now we have acylation. Acylation may be same hoga. This thing plus this thing would give me the formation of this acylonium ion. So this acylonium will be formed, plus charge hai, nucleophile hai. Once again the reaction will occur, giving me the formation of the compound at the para position to be the major one. Okay. Next we have some reaction with the metals. The first one is the Wurtz-Fittig reaction, just discussed it. What will happen? The removal of 2 NaX will happen, giving me the formation of this compound, and some NaX will also be formed. Okay, so this can also be used in order to generate the aryl halides, or basically the aryl compounds here. Next we have the Fittig reaction. Once again you can see that the removal of this happens, that is NaX is removed, giving me the formation of the compound which is known as biphenyl. Okay, biphenyl. Next is Ullmann's reaction. Similar thing happens here, but isme iodine hota hai and Cu powder is there. Removal of this happens, giving me the same biphenyl product to be formed. But the name reaction hai, that is why this should be known to you. Next we have the dihalogen derivatives. Dihalogen basically means we have the two halogens to be present on the compound. Like this is a dihalogen compound, okay, which is, now this thing is important, this is known as a vicinal halides. Vicinal halides ka basically matlab hota hai that the halogen is present on the adjacent carbons. Or we can also have the gem dihalides. Gem dihalides are those in which the halogens are present on the same carbon. So these two terms should be clear. Vicinal matlab on the adjacent, gem dihalide means on the same carbon. Dichloromethane, that is CH2Cl2, that is a dihalogen derivative, is widely used as a solvent. You would have seen this many times in the labs also, as a propellant in aerosols. Direct contact of CH2Cl2 in humans causes intense burning because the skin becomes yellowish type. Okay, it happened with me. And the milk readiness of the skin. Okay, it depends that in which compound we are reacting. It can either become yellow also, or it can also become some milk red type of structure on the skin. Okay, so that is, it is kind of harmful. Now we have the trihalogen derivatives. Now trihalogen derivatives means that 3 halogen hone wale hain. The first and the most common example is chloroform. Let us see some methods of preparation. First and the most common is the reaction of methane with 3 moles of Cl2 in the presence of light. Radicals will be formed. That gives me the formation of CHCl3, that is chloroform, plus 3HCl. Now we are dealing with the haloform reaction. Haloform reaction and its mechanism will be clearly dealt in the future chapters. But let us try to see usme hota kya hai. We have C2H5OH plus Cl2. That gives me the formation of CH3CHO plus 2HCl. That is, oxidation is happening out here because alcohol ka oxidation karke kya banta hai? Aldehyde. Okay. Now we have the aldehyde. We take Cl2. Now in this case we will get the chlorination to occur. So these 3H which are present now are replaced by the chlorine. Okay. So what in the presence of basic medium? We get the formation of CCl3CHO plus 3HCl. Now CCl3CHO is also known as chloride if present with water. So now this compound is taken, that is CCl3CHO is taken along with calcium hydroxide. We can obviously take it with NaOH also, that is basic medium also. In 2 moles, that gives me the formation of 2CHCl3, okay, which is known as chloroform. A very famous reaction, haloform. Chlorine hai, isliye chloroform. If it would have been CHI3, it would be iodoform. Okay, now let us see some properties here. The oxidation of CHCl3 gives poisonous gas phosgene. Like we have CHCl3, we take O2, okay, in the presence of light, it gives me the formation of COCl2, which is known as phosgene. So very harmful. That is why we don't try to use it in the labs, because oxygen is present everywhere. So we can get phosgene, which is very harmful for us. Now what we do in labs is basically to avoid this oxidation. The CHCl3 is stored in dark brown bottles and filled to the brim. Like in the labs, you would have seen that there are some desk type of structure which are present, the drawers. Inside that we are keeping the CHCl3. 1% ethanol is also added to the chloroform, which helps in converting the harmful phosgene gas into diethyl carbonate. Now CHCl3 is widely used in the production of the furon refrigerant R22. Given in the NCERT, should be remembered. Okay. On nitration, it gives tear producing insecticide, that is chloropicrin. Chloropicrin can also be formed, so this should also be known to you. Okay, so I hope that this point is clear. Now these points should be remembered. These are given in the NCERT. Now we have the next trihalogen derivative, which is the iodoform, which is CHI3. Now CHI3 is prepared by the iodoform reaction. Now I can guess that iodoform reaction में क्या होने वाला है? We have CH3, C double bond O CH3. We take 3 moles of I2 and 4 moles of NaOH, that is in a basic medium. We get the formation of CHI3. Now CHI3 is the iodoform which will be formed. Like in this case, we get the formation of chloroform. In this case, we get the formation of the iodoform. So iodoform will be formed in this particular reaction. Now the compounds which either contain CH3 C double bond O minus or this particular OH group form yellow color with I2 and NaOH. This would be dealt in the carbonyl compounds. Okay, so you can wait for it. Iodoform, when it comes in contact with the organic matter, decomposes easily to free iodine, that is an antiseptic. Now what actually happens is that the iodine has a very objectionable smell, that it smells very bad. If you would have gone to the laboratory, you know it. Then it has been replaced by other formulations which contain some derivatives of iodine. Okay, direct iodine is very, it has a very pungent smell. So that is why we take some formulations which contain iodine but have a good smell. Now polyhalogen derivatives, the first one is the CCl4. How it can be prepared? You can guess it very well. We have CH4. We take 4 moles of Cl2 in the presence of light. We get the formation of CCl4 and HCl. So CCl4 form ho gaya. We can take chloroform also, that is CHCl3. We take 1 mole of Cl2. We get the formation of CCl4. So this can also be formed in this particular manner. Okay. Now the uses of this carbon tetrachloride is that it can be used as a solvent for oils, fats and resins. It can also be used in a dry cleaning. It can also be used as a fire extinguisher under the name pyrene. Okay, very important point. So please remember these. Okay, that is why only this video has been made, so that the important points are discussed and you don't have to study the NCERT. Okay, now we have the furons. You would have definitely seen these structures. The furons are present in the refrigeration, air conditioning purposes and aerosol propellants. The chlorofluorocarbons of methane and ethane are collectively known as furons. Fluoro, that is chlorine is also present, fluorine is also present. Now carbon tetrachloride, that is CCl4, when it reacts with antimony trifluoride in the presence of SbCl5 as a catalyst, this is a very common catalyst, then dichlorofluoromethane is obtained. Dichlorofluoromethane matlab dichloro matlab 2Cl fluoro. Okay, so this structure would be formed. Okay, so this is also known as a furon. Okay, it has been said derivative of methanes and ethanes. Now we have the DDT part. Now this has a very special place in my memory. I will tell you why. Now DDT is first chlorinated organic insecticide. Very important. But its stability and the fat solubility is a great problem. It is very stable and it is fat soluble. That is why it is the biggest problem. It is prepared from chloral and chlorobenzene in the presence of concentrated H2SO4. Now this is the structure of DDT. Now why this has a very special place in my memory? Because in bit set which I had given, they had asked that how many chlorine atoms are present in DDT. Okay, so you can see that कैसे कैसे question आते हैं. So you should know that there are number of atoms in chlorine, that is the number is equal to 5, and that is present in DDT. So this is the structure of DDT which I have drawn for you here. The last part is the perchloroethane, which is C2Cl6. It is used as a moth repellent and it is also known as the artificial camphor. In Hindi में क्या बोलते हैं, कपूर बोलते हैं जिसको. It is used as a moth repellent and artificial camphor. So please don't forget to like this video. It takes a lot of effort in developing these PDF जो पहले मैंने print कराया, उसके बाद then handwritten which I have written. Okay, please don't forget to share this video. Okay, so if there are any doubts, please mention in the comment section. Also mention the homework, that is ortho or para, in the comment section. So thank you and all the best.